Hi guys, it's Shah here, the TechBorg, and this video is on geometric series. The last one we were looking at is arithmetic, and if you remember, arithmetic had a D for common difference. A D for common difference. But we are not going to have a D. Let me just quickly change the pen, something more smooth. This is, oh my god, I don't think this should be it. Okay, that's okay. So if you remember, we had D for common difference in the arithmetic series, but now we're looking at geometric series. So let me show you how that's done. Let me just remove all this. Cut. Right. So in geometric series, we have a multiplier or a divisor. So by that I mean we have let's say we had a series 2, 4, 6, 8. Sorry, no. A small mistake. 2, 4, 8, 16, 32. Okay, so as you can see, we're not increasing by the same amount. Are we adding plus 2? No. What we're actually doing is multiplying by 2 each time. So you can say times 2 times 2. So as you can see, we're multiplying by 2 each time, and just by looking at this you can tell it's 2n. But we want to know how to derive this from the original formula. So if I just remove this again, cut. And so the formula for geometric series is slightly different. So it's un, sorry about that, un is equal to ar to the power of n minus 1. So what this really represents is n is the term number like always, a is first number like always, but r is the common ratio, and the common ratio is the multiplier. So it's like times 2 or divide 2 or times a third, or it can be anything as long as there's like a multiplier or divisor there. And these kind of questions are normally to do with interest questions, like after 5 months, how much interest does he get if he gets 10% compound interest. So that's what you can use this for. So let me just go over something quickly. So if I just remove this, cut. So un, so let me just write it down. Un is equal to ar to the power of n minus 1. Sorry, the power of n minus 1. And the reason it's n minus 1 is because because we're assuming that the zeroth represents, the first represents the 0th month. So let's say we had first month you get 200, and then you earn like 20% extra each month. So that's times 1.2, right? So that's basic compound interest. So times 1.2 times 1.2, and let's say we want to find out what it is for the third month, right? Third month, first, second, third. So let's say we want to find out for the third month. But this is the 0th month, let's not forget. But the term number is still 1 if you think about it, because on the first month, do we get the interest? No, we get it after the first month end. So technically we get it on the second month. So on the first month we're only getting 200, which is our base, which is what we put in, imagine. So a is 200, and the term number for the first one is u1 is equal to a, which is 200, times the common ratio, which is 1.2, to the power of 1 minus 1. And as you can see, it becomes 0, and that leads to 200, which is what your initial value was, which is correct. And let's say we want to find the third month now. So it's just u3 is equal to 200 times 1.2 to the power of 2, because you do 3 minus 1, which is 2. And that will give you the answer. I sadly don't have a calculator on me at the moment, so yeah, so I can't solve it, but that's literally how you do it. It's as straightforward as that. And now we need to go over the sum of the series. I'm not going over many examples at the moment, but I will eventually upload some videos that have those specific examples at least. But for now, let me just, I guess, teach it to you. So the sum of the series, so we know that un, so let's say we want to sum up the series. So S represents the sum of the n terms of the series. So that's A, AR, AR squared, AR cubed, etc. And if we, this time we're not going to flip it though. This time we're going to multiply everything by R. R is equal to AR, AR squared. Sorry, there should be a plus sign in between all of these. Plus AR plus AR squared plus AR cubed, and eventually you reach AR to the power of n. And this one is AR to the power of n minus 1. Because we timed it all by R, we're adding an R value in it, so it's going to change it. And so yeah, and if we add these two together, minus Sn minus Rsn, so Sn minus Rsn, you get A minus AR, AR minus AR squared. So let's just say we pick one of them out, A minus AR, right? So if you think about it really carefully now, so guys, as I was saying, so if we minus them all from each other, AR would cancel, this AR would cancel with this AR, that with that, that with that, and eventually you'll be left with AR to the power of n and A. So A minus AR to the power of n. So if I just scroll down quickly and show you Sn, if we factorize the Sn, we get 1 minus R is equal to A minus AR to the power of n. And then if we scroll down even further, Sn is equal to A minus AR to the power of n over 1 minus R. So that's the formula, but how you're meant to know it is, let me show you how you really should present it, is A 1 minus Rn over 1 minus R. So this is how you should present the formula, not like this. This is just a simplified version. It's the same thing. As you can see, we just factorized the A from here to get that. Anyway, and that's really it, to be honest, guys. But we also need to know one more thing for geometric series, and that's sum to infinity of a series, and I shall cover that now. Okay, so if I remove all this, you guys take notes or something if you want to by rewinding the video. Let me just cut this out. So let's say we want to find the sum to the infinity of a series that goes on forever, and let's say the sum, let's say the formula, well, to be honest, we have to first prove the sum to infinity of a series, and you need to know the formula. So sum to infinity of a series is A over 1 minus R, and R must be strictly between less than 1 or more than minus 1. That's its deviation, that's its range. That's the value of R that M has to be. So that's something you have to keep in mind, guys. So the reason we get only A1 minus R, so if we know the original formula 1 minus Rn over 1 minus R, have you ever wondered where this went? If you think about it, let's say a series went to infinity and it converges to a point. If it reaches infinity, R to the power of n will eventually reach 0. So as sum to the infinity, as n approaches infinity, Rn approaches 0, and if Rn approaches 0, we get A 1 minus 0, and you're just left with A over 1 minus R. And that's something for you to think about. It's quite interesting. I'm quite sure you don't need to prove that, but I mean, it's something really straightforward. You just need to say as n approaches infinity, Rn approaches 0, and yeah, that's it. And you just have to plug in the value of your A and the value of your R, and again, it has to be less than 1 and more than minus 1, and something to keep in mind. And I hope you guys enjoyed this video, and it covers everything you need to know about geometric series, and I shall make more videos on the problem solving side, but mostly these videos are there to teach you on literally how to understand these type of questions on series. So I hope you guys enjoyed again, and thank you for watching, guys. Like, comment, subscribe.